All right, we are starting our next unit, which is all about sequences, and the first section that we're starting with is 5.1, talking about arithmetic sequences. So before we get started, we'll talk about what is an arithmetic sequence, and that is just a list of numbers that follows a pattern of adding or subtracting the same number each time. So a sequence is just a list of numbers that follow some sort of pattern. Something is happening every time that we can continue to do to get the next numbers in the pattern. So for arithmetic sequences, every sequence we look at today will be adding the same number each time. Or we might see it as subtracting, but if we're subtracting, that's the same thing as adding a negative number. So we're just going to think of this as arithmetic sequences add the same number every single time to get the next terms in the sequence. So looking at this first example, we have the pattern or the sequence 0, 3, 6, 9, 12. So just looking at that, we should be able to tell what's happening every time. To get to the next number, we are adding 3, and that happens every time throughout that sequence. And then we're going to put these numbers into a table. So term number is just where is that number in the sequence? What position is it in? So we have the first term, the second term, the third term, the fourth term, and the fifth term. And the first term is 0. The second term is 3. The third term is 6. The fourth term is 9. And the fifth term is 12. Okay, before we talk about coming up with a rule, I just want to visualize this sequence on our graph. So I'm going to graph these points 1, 0, and 2, 3, and 3, 6, and 4, 9, and 5, 12 is going to be off my graph, but we have 4 points up there already, so that is good enough for us to visualize this pattern. And it looks like something we already know that has a constant rate of change. So if we look at these dots, they are in a straight line, which means this is similar to something we've already learned this year, which is linear equations. So arithmetic sequences are linear patterns. They have a constant rate of change. They are going up or down by the same number each time. Okay, so that means if we think about what we know about linear equations, we know that we could look from one point to the next point and look at the rise over run, which in this case is going up 3 over 1, and 3 over 1 is just 3, or the same thing that we figured out here. So the slope is 3, and that number there is also 3. We're going up by 3 every time. And the rule, we need to know 2 different things. So if we're thinking about writing the rule, we could think about what we know about linear equations. Think back to y equals mx plus b. And looking at that, we know we had to plug in the slope and we had to plug in the y-intercept. So when I write this rule, first thing I'm going to know is the slope. What are we adding every time? What is that change? And in this case, it is 3. And then instead of x, for sequences, we are going to use the variable n. So we have 3n, and then we know in a linear equation the second part that we need is the y-intercept. So if I go to my graph, we know we could use the slope and work backwards to get what that next point would be on our y-axis. And that point could also be seen in our table by going back to 0 on the x, and that y value is at -3. And we could figure that out just looking at our table too. We know we're going up 3 each time, so if we work backwards and go down 3, we're at -3. So that gives us the second part of our rule. So to come up with a rule for an arithmetic sequence, we will learn a different equation that we're going to use. But for today, let's just think of it like our linear equations. It's similar, but it's not the exact same. But we need to know what's happening each time. That comes first, times n. And then what would the term before the first term be? And in this case, it was -3. This number right here, the one that we're adding each time, that is called the common difference. And we'll go over that vocab word in the next lesson too, but for now, just know whatever we're adding each time is called our common difference. So example 2, if we go down to this one, this time we are going from 4 to 2 to 0 to -2 to -4. So we can think of this as subtracting 2 every single time, or adding -2. But in this case, our common difference, which we abbreviate with a D, our common difference is -2. So that's going to be the first part of our rule, -2n. And then we'll fill out our table. So the first term is 4. The second term is 0. The third term, the second term is 2. The third term is 0. The fourth term is -2. And the fifth term is -4. I'm going to sketch these points on the graph. So we have 1, 4, 2, 2, 3, 0, 4, -2, and 5, -4. Okay, if we follow our pattern, we know this is going down 2 over 1, down 2 over 1. That's our slope. So if we follow that to work backwards to the y-intercept and go up to left 1, our y-intercept would be right there. We could figure out in our table, if we go back 1 to 0 and go back here, each time we were subtracting 2, so working backwards, we will add 2 to get 6, which is the same point here, 0, 6. So that's the second part of our rule, plus 6. So our rule, we have -2n. -2 was what's happening each time, plus 6, and 6 was the number that would be before the first term. Okay, we'll do just one more, and then the rest of these are just here to help you. You can try them. The graphs are just there to help you visualize and make connections with the linear equations that we already have learned and know. But the important thing is being able to come up with the rule. So whatever works for you to figure that out is fine. If we go on this one, we are adding 4 every single time. So our common difference is 4. So for the rule, we'll write 4n, and then I'm going to complete the table. The first term is -5. The second term is -1. The third term is 3. The fourth term is 7. And the fifth term is 11. If we want to figure out the rest of this rule, we just need to go back one and find the term before the first one. What would that be if we had it? And if we go back one, that would be at -9, because every time here we are adding 4. So if we subtract 4, that puts us at -9. So this rule is 4n minus 9. Okay, so hopefully those 3 examples help. For every rule, you just need to figure out this number here in front of n. What's our common difference? What are we adding each time? And what would be the term before the first one? And we can always check these rules also. Just know that if we plug in any of the term values, then we should get, or any of the term numbers, we should get the value over here. So if we plug in our first term, 4 times 1, and subtract 9, that gives us -5, which is the value here. So we can double check that to make sure we got the right rule, and we got it.